Oh, I love Miss Chemistry.
Now, good day everyone. My name is Daniel Go. On the board, we're having calculations on mole concept. Number one, how many moles of chlorine are required to react with 2.5 moles of calcium to produce calcium chloride? Now, when it comes to questions like this, the first step is to always balance the equation. Always balance the equation. And the second step is to write out the molar ratio. If I say molar ratio, is the ratio of the coefficient of the reactants to the product. Step 3 is to write out the two relating substances. The two relating substances. Now, question 1 now. Now, 1 mole of calcium reacting with 1 mole of chlorine to produce 1 mole of calcium chloride. We have, let's say before we finalize, we have 1 calcium here, we have 1 calcium here, we have 2 chlorine here, 2 chlorine here, so it's balanced. So, from the equation, 1 mole of chlorine is required to react with 1 mole of calcium from the equation. Now, what's the question now? How many moles of chlorine are now required to react with 2.5 moles of calcium? Now, remember, writing out the two relating substances. One must be the unknown, and the second one must be the one having value. From the question now, how many moles of chlorine? So chlorine is the first one. So chlorine is in question. The second one must be the one with value. How many moles of chlorine are required to react with 2.5 moles of calcium? So calcium is having value, so it's the second one. So from the equation, 1 mole is reacting with 1 mole of this. So from the question now, how many moles of chlorine are now required? How many moles of chlorine? So we have X mole. Are required to react with 2.5 moles of calcium Now, from the equation, 1 mole of chlorine are required to react with 1 mole of calcium. So we are having 2.5 moles here now. How many mole of chlorine will now be required to react with this 2.5 mole of calcium? Cross multiply. So it means that 2.5 moles of chlorine are required to react with 2.5 moles of calcium. Since 1 mole is required to react with 1 mole of calcium, so we need 0.5 mole to react with 2.5 mole of calcium. Now, question 2 now. Question 2 says that how many grams of oxygen are required to react with 0.3 mole of aluminium to produce aluminium oxide? Let's try to balance the equation. How many aluminium do you have here? We have 1 aluminium here. We have 2 aluminium here. So we put 2 here. So we have 2 aluminium, 2 aluminium. We have 2 oxygen and we have 3 oxygen. So let's put 2 here. So right here we have 4 oxygen, 3 oxygen. So let's put 2 here. So we have 2 aluminium, 4 aluminium. So let's put 4 here. So you have 4 aluminium, 4 aluminium, 4 oxygen, 6 oxygen. 2 times 3, 6. So we have 6 oxygen now. 4 aluminium, 4 aluminium, 6 oxygen, 6 oxygen. Balance. So what's the next thing? Write out the molar ratio. So from the equation, we are having 4 mole of aluminium reacting with 3 mole of oxygen to produce 2 moles of aluminium oxide. So the next thing to do was write out the relating substances. Now, how many grams of oxygen. So oxygen is the first one. Are required to react with 0.3 mole of aluminium. Aluminium here, this aluminium here is having a value which is what? 0.3 mole. So aluminium is the second one. So from the equation now, we have 4 mole of aluminium reacting with 0.3 mole of 3 mole of oxygen. But mind you, the question says that how many grams of oxygen, not how many moles. It means we convert the mole here to what? To mass, which is measured in gram. And how do we go about that? Now pay attention. Now, 1 mole of oxygen weighs what? What the mass of oxygen is what? 16. But how many oxygen do we have here? We have 2 oxygen here. That will be what? 16 times 2, which is what? 32 grams. So, we want to leave oxygen as mole because they said that how many grams of oxygen. So we convert oxygen to what? To mass, which is measured in gram. Now, 1 mole of oxygen molecule weighs what? 32 grams. Now, we are having 3 moles here. If 1 mole weighs 32 grams, now 3 mole will weigh what? That will be 3 times 32. So you have 3 times 32, which equals to what? 96 grams. So 3 mole will weigh what? 96 grams. So we are converting mole to gram. (96 grams). Now this one here now, we leave it as mole. Why? Are required to react with 0.3 mole of aluminium. So we leave mole with aluminium because they said that 0.3 moles of aluminium, but here grams of oxygen. So from the equation, 96 grams of oxygen are required to react with 4 mole of aluminium from the equation. And what's the question now? How many grams of oxygen? So we have X gram. are required to react with 0.3 mole of aluminium. So what's next thing? Cross multiply. Now 0.3 multiplied by 96 now. Right, so we're having 28.80. So 28.80 like before. So we have I put gram here because we're having what? X gram. So 7.2 gram of oxygen are required to react with 0.3 mole of aluminium to produce aluminium oxide. Number 3 now. Number 3 says that calculate the mass of calcium chloride produced when 40 grams of calcium carbonate reacts with hydrochloric acid or hydrochloride. So now, let's balance the equation now. 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygen, 3 oxygen, 1 oxygen here, 2 oxygen here, making 3 oxygen. 1 hydrogen here, 2 hydrogen here. So we'll put 2 here. Now 2 chlorine here, 2 chlorine here. So it's balanced now. So molar ratio now. Remember, I said that no matter how long or how many the substances you might have, your attention will be drawn to just 2. The unknown and the one with value. The question now. Calculate the mass of calcium chloride. Calculate the mass of. So the unknown here is calcium chloride. produced when 40 grams of calcium carbonate. So calcium carbonate is having value. So from the equation now, we have 1 mole of calcium carbonate reacting with hydrochloric acid to produce 1 mole of calcium chloride. Now the question now, we will leave this one. I'm going to leave it as mole. I will convert it to mass. Let's check. Calculate the mass of calcium chloride. So what happened there? You are converting mole here to what? To mass. You won't leave it as mole, but you convert it to what? To mass, which is measured in gram. So 1 mole of calcium chloride weighs what? Now let's solve it now. In calcium chloride, we have those two elements, which are calcium and chlorine. How many calcium do we have? We have just one. Now 1 mole of calcium chloride now. How many calcium do we have here? 1. What's the mass of calcium? You have 40. How many chlorine do we have here? 2. What's the mass of chlorine? 35.5. So 1 mole of calcium chloride weighs 1 gram. So here we are having 101 gram. Mass of calcium chloride, 40 grams of calcium carbonate. So also converting calcium carbonate also to mass in gram. In right here, in calcium carbonate, we are having calcium, carbon, oxygen. How many do we have here for calcium? 1. Carbon, how many? 1. Oxygen, how many? 3. Mass. Carbon. And oxygen is what? 60. We are having what? Calcium is what? Mass 14. Carbon is what? Mass is what? 12. Oxygen, mass is what? 16. We have 1 calcium here, 1 carbon here, 3 oxygen here. So 1 mole of calcium carbonate weighs what? 100 grams. Now please take notes. Very, very compulsory. If we have 2 here, it means we multiply anything we get times 2. If we have 3 here, what we have here will be what? Multiply by 3. But since we have just 1 here, we leave it like that. 1 mole of calcium carbonate weighs 100 grams. So this 1 times 1 will still give you 100 grams. Now, calculate the mass of calcium chloride produced. Calculate the mass of, so it is unknown, produced when 40 grams of calcium carbonate reacts with hydrochloric acid or hydrogen chloride. So what's the next thing here? Cross multiply. So our final answer is what? 44.4 gram. 44.4 gram. So the mass of calcium chloride produced when 40 grams of calcium carbonate reacts with hydrochloric acid is 44.4 grams. The mass produced when we use 100 grams, the mass produced is what? 101 grams. Now, when we now use 40 grams, you get what being produced? 44.4 grams produced.